everyone, welcome to Leetcode Simplified. Today we're walking through the two-sum problem. Clean and efficient way to solve this problem using a simple idea that you will see over and over again in coding challenges. Let's get right into it. So here the problem goes like this. Given an array called num and a number called target. Guarantee there are two different numbers in this array that will add up to the target. Find them and return their indices. For example, given this array and the target number 9, so you should return the indices of 2 and 7, which is 0 and 1. So here's the idea. Keep a dictionary called hashmark that store the numbers we already seen along with their indices when we traverse through the array. Because for each number we looked at, we can always ask, what number should we need to pair with this number to reach the target sum? So we call that number the complement. It's just a target number minus the current number we are visiting. Let's say we are at the current number 7 and the target is 9. The complement of 7 is 2. Check in the dictionary. Have I seen this number 2 before? If yes, there's the answer. 2 and 7 are the two numbers that add up to 9, and we will return their indices, which is 0 and 1. If not, we store the number and we keep going. Let's head over to Python. Map. So we're going to loop through this array using enumerate, a built-in Python function to retrieve the index of the number together with the number. For the index and the number itself, in the object enumerate of nums, calculate the potential complement, and we save it into the complement variable. If the complement in the num map dictionary, return the index of the complement and the index of the current number. Now, if the complement isn't in the dictionary, we need to store the current number with its indexes so we can use it later if needed. Let's submit our solution to Leetcode. Moment of truth. Boom, accepted. That's our solution to the two-sum problem. This approach is powerful because it lets us find the answer as we loop through without checking every pair of numbers. The key is using the dictionary to remember what we've seen. So anytime you're solving problems that ask about finding pairs or checking if something exists based on earlier values, this pattern is worth remembering. That's it for a two-sum problem. If this helps, subscribe to Leetcode Simplified for more tutorials like this one. Thanks for watching and keep practicing. Hi everyone, welcome to Leetcode Simplified. Today we're solving two classic palindrome problems, and we do it in a clean and efficient way by converting the problem into a form that's easy to check. Let's get right into it. Palindrome number. Given an integer x, return true if x is a palindrome, meaning it reads the same forward and backward, and false otherwise. 1 to 1, read backward. 1 to 1, the same. Minus 1 to 1, not the same as 1 to 1 minus. 1 0 is different from 0 1. It's not a palindrome. So what is the idea? Convert the number to a string, which is easy to check whether it's equal to its reverse. Let's go to Python. Convert the number to the string, save it into a variable called string underscore x, and compare that string is the same as its reverse, and whatever return true or false. That's how simple it is. Submitted to Leetcode. Boom, accepted. Let's move on to Leetcode 125, valid palindrome. Very similar to the last one. Given string s, determine if it's a valid palindrome. But here's the catch. You need to ignore non-alphanumeric characters and treat the uppercase and lowercase the same. For example, giving you this string, after you convert it, it becomes this string, and reverse reading is the same. So it's a palindrome, so the output return true. It's not the same for this string, race a car. After you do the conversion, you read backward, not the same, so it's false. Let's write that in Python. Go through every character, do the conversion. For every character in S, if that character is alphanumeric, then we'll lowercase that character. And then join all the character in string S without space. So now the string s become this string. Save it in a variable called clean. Now we just compare each clean string is the same as its reverse, and whatever valuation becomes, return it. Okay, submit it to Leetcode. Boom, accepted, super clean. So what's the key takeaway? The main idea in both problems is this: one, you convert your input into the right format. Checking for palindrome becomes really easy, just compared to its reverse. This pattern, transform then compare, come up a lot in string problems. That's it for today's video. Hope it's helped. Give it a thumbs up and subscribe to Leetcode Simplified for more and quick tutorials just like this one. Thanks for watching and keep practicing. Do you know how to convert Roman numeral to the normal number system that we use today? Did you know there's a special rule in Roman numerals that actually goes against how we naturally think about numbers? Today we're walking through the Roman to integer problem. We will explore a clean and clever way to convert it into an integer using a simple idea that handles all cases correctly with just one pass through the string. Let's get right into it. Given a string that represents a Roman numeral, convert it to its integer form. Here's the idea that gets the job done in the optimal way. Go to the Roman numeral from right to left. For each character, compare its value with the previous one. If it's larger, add. If it's smaller, subtract. Let's walk through these following examples step by step. Scan through every single character from right to left. Compare its value to the previous one. If it's larger, add. If it's less, we subtract. Given this string, scan from right to left. The first one is value 1. Its previous, which we assume is 0, so we add 1. The next one, also 1 is the same, so we also add. Now we go to the last character, its also value is 1. The same, the previous one, so we also add. So the total 1 plus 1 plus 1 is 3. These values start with I. Its 1 is greater than its previous 0, so plus 1. Next one is also another 1, so we add. The third one, 1, same thing is 1, so we also add. Now V value is 5, greater than 1, add. L value 50, greater than its previous 5, add. The total is 58. How about this one? We start with V, 5, greater than 0, we add. I, 1 less than 5, then we subtract it. C is 100, greater than previous value is 1, add. Move to the next one. X is 10, smaller than its previous value, 100, subtract. And go to M, 1000, greater than its previous value, 10, add. Now C is 100, less than its previous value, 1000, subtract. And then the last one is M, 1000, greater than 100, add to the overall value. Overall total is 1994. We just did convert this string to its integer values. Okay, so as given this, we're going to copy the symbol and its values. Create a dictionary using the given information. So we call it dictionary Roman equal, and then I'm going to paste it in. I'm going to make a dictionary. That is our dictionary. Initialize the total with 0. We're going to compute that number and return that. At the end, it's 0 for now. So for each character from right to left, we retrieve the value of that character and we save it in cur. If cur is greater than equal the previous values, initialize it with the value 0. So we just add to the overall total. L is smaller. Now this is the crucial step that goes against our instant processing in the mind. Subtract the current value from the overall total. Update the previous values with the current value before we move on. Return the total. Alright, submit it to Leetcode. Boom, accepted. This approach works in time on and is very efficient for any valid Roman numeral input. That's it for Roman to integer problem. If this helped, give it a thumbs up and subscribe to Leetcode Simplified. Hi, I'm Alan. Welcome back to Leetcode Simplified, where we simplify coding problems and breaking them into simple steps. Today, we're solving Leetcode 14, longest common prefix. It's a classic string problem that often shows up in interviews, giving a list of strings. Find the longest common prefix amongst them. If there are no common prefix, return an empty string. For example, this list of strings, common prefix among all of them is FL. FL stock right here in this string. FL stock right here. FL also stock in this string. So FL is the longest common prefix amongst all the three strings. This list of strings, this start with D, this start with R, this start with C, have no common prefix to start with. Return an empty string. Here are the steps. If the list is not empty, we assume the first string as the prefix and check if all the strings start with it. If not, shorten the prefix and try again until all the strings in the list start with that final prefix. At this point, the final prefix is the longest common prefix of all the strings in the list. At any time while we performing the process of shortening the prefix and the prefix become empty, terminate the process immediately. No common prefix. Let's go through the below example step by step. Assume the first string is the prefix. Flower is our prefix now, and we're going to use it to test against each and every string in the list. Test it with flow. Flow start with flower? No. So we chop the last character from the prefix and try again. Flow start with flowy? No. Chop the last character from the prefix. String flow start with prefix flow? Yes. Move on to the next string and test it with prefix flow. Fly start with flow? No. Then we chop the last character from the prefix and try it. Does fly start with flow? No. Chop the last character from the prefix. Test it with fly. Does fly start with FL? Yes. Go to the next one, but we have no more string to test. The current prefix right now is FL, and that will be the common prefix amongst all the three strings. Now take a look at this example. First, assume the first string is the prefix. Save it to the variable called prefix. So dog is our prefix right now. Use dog to test against each and every strings in the list. Shorten the prefix accordingly. Let's test it with race car. Does race car start with dog? No. Okay, how about this one? Does race car start with do? No. How about this one? Does race car start with D? No. Chop. In every step, after we chop the last character, always check if the prefix is empty. Currently it is. The prefix right now is empty. Immediately terminate the loop and return the empty string. Now let's walk through the actual code together in Python. First thing first, check if the list is empty. Return empty string. Get the first strings at position 0 and we assume that is the answer. Prefix. Test this against all other strings in the list. Scan through every other string in the list starting from the second one. If the current string not start with the prefix, we will chop the last character from the prefix. And if we want to do it again, why is the string not starting with the prefix? If prefix is empty and the loop return the empty string. At the very end, we return the final common prefix among all the strings in the list. Now let's submit it. Voila! Accepted. And that's it for today. We use a simple while loop and a few string comparisons. Get the job done. We assume the first string is the prefix. Keep trimming it down until it's common amongst all the other strings. This algorithm avoids complex comparison. And that's it for today. For the longest common prefix problem, if this helped you, give it a thumbs up and subscribe to Leetcode Simplified. Welcome back to Leetcode Simplified. We break down problems into clear and simple steps. Today we're solving problem 20, valid parentheses. Given a string S contains only parentheses, determine if it's valid. We need to check if the brackets are closed in the correct order. This is perfect for a stack. Here is a simple idea. Go through each character. If it's an opening bracket, push it onto the stack. If it's a closing bracket, pop the stack. If it's not empty, and check if it's the pair with the closing bracket we are at. If we are able to read through the last character, return true. If the stack is empty, that means every open bracket has a matching closed bracket in the correct order. Let's take a look at a few examples. When we see an open bracket, push it into the stack. We go to the closing bracket, pop this one out, and find its matching. Its matching pair, this one is at the same as that one. So return true. Next one, opening bracket, pushes into the stack. Closing bracket, then we pop this one out and find its matching pair, which is this, same thing as that. Go on to the next one. So open bracket, push it into the stack. Move on, closing bracket, then we pop this one out, find its matching pair, compare it, same thing as that. Go on, next one, open bracket, push it into the stack. Go on, closing bracket, then we pop this item. Its matching pair is that, same as this. At this point, it will read through all the characters and the stack's empty. The string is valid parentheses. This one, first one is open bracket, push to the stack. Closing bracket, pop the stack. Its matching pair, this one. Is this the same as that? No. Immediately return false. Last one, open bracket, push it into the stack. Another open bracket, push it into the stack. Closing bracket, pop this one out. Its matching pair is this, the same. Then move on. This character, closing bracket, pop the stack. This item is matching pair, same as that one. No more character to read, and the stack is empty. The string is a valid parenthesis. If we're clear on the example, let's head over to Python. So the first thing is to build a dictionary so we can reference to it anytime we want. Call it a pair. Create a stack. Now scan through every character in string S. If the character is the open bracket, this, push into the stack. If the stack is empty, return false immediately. If the stack still have an item to pop out, it will pop out that item. Find its matching pair. Check if it's the same as the closing bracket we are reading right now at the moment, and if it's not, also immediately return false. Otherwise, if it's the same, move on to the next character. Repeat, iterate until no more character to read. We return true. If nothing in the stack, let's submit it to Leetcode. Finger crossed. Successful. Accepted. That was valid parenthesis. Welcome back to Leetcode Simplified, where we make coding problems easier to understand, one step at a time. Today, we're solving Leetcode 21, Merge to Sorted List. Classic linked list problem that tests ability to manipulate pointers and build a new list. Given two sorted linked lists, merge them by splicing together the node of the two lists. Here are the steps. Use a dummy node and a tail pointer to walk through the two lists. Compare values and connect the smaller one to the merged list each time. Once one list is empty, attack the leftover nodes from the other list. Return dummy.next as the head of the final merged list. Let's look at the example below and watch how the pointer do the magic. When it comes to linked list, seeing is understanding. The problem gives us two pointer, list 1 and list 2, that point to the head nodes of the two sorted linked lists. Create a list node object and set pointer dummy to point to it. I also create pointer tail that also point to the same list node as dummy. So far, list 1 point to the head node of the first list, list 2 point to the head node of the second list. Dummy and tail point to dummy list node. Now look at the two head nodes, compare the values. If value in list 1 is less than or equal value list 2, point the next pointer up tail to list 1. Advance list 1 pointer. Move tail to the node it just connected to. Repeat the process to look at the two head nodes 1 and 3. Point the tail next to 1. Advance list 2 pointer to the next node in line 2. And point tail pointer to the node it just connected to. Now node 3 is the head of list 1 and node 2 is the head of list 2, which is smaller. So point tail next to node 2. Advance list 2 pointer to the next node in line. Advance tail to the node it just connected to, which is 2. Repeat. So node 3 is the current head of list 1. 4 is the current head of list 2. So tail will point next to node 3, which is smaller. Advance list 1 pointer to the next node in line 4. After that, tail will advance to the node it just connected to, node 3. Repeat. List 1 head is node 4. List 2 head also 4 equal. I will point tail next to node 4 in list 1. And now list 1 will advance to none. Tail move to the node it just connected to, node 4 in list 1. This time process will not continue because one of the list is none. Loop terminated. Point tail next to whichever list is not none, list 2. Finally, return dummy.next which point to this node, node 1, the head of the merged linked list, which is connect 1 to 1 to 2 to 3 to 4 to 4. If everything is clear so far, let's write the Python code to make it happen. First, make a list node, make a dummy pointer, point to it. Then create another pointer called tail, which also point to the same list node as dummy. While list 1 and list 2 exist, do the following. If list 1 value less than or equal list 2 value, set tail next point to the same node that list 1 point to. Then move list 1 to point to its next node. Else, do the same. Tail next point to list 2 and advance list 2. After connect tail to the smaller node and move to the next node available, now it's time for tail to advance to the node it just point to. Point tail next to this one if this one still exists, else list 2. Finally, return the merged list dummy.next. And we're done. Okay, let's submit to Leetcode. Moment of truth. Whoop, typo. List 1 point to the next node. Try again. Boom, accepted. We successfully merged two sorted linked lists using pointer manipulation. Hi friends, Alan here, and this is Leetcode Simplified, where we'll make problems easy to understand. Today's problem, Leetcode 26. Remove duplicate from sorted array. Given a sorted array, remove duplicate in place. That means no extra space allowed. Modify the array directly that the first k element are unique elements and return k. Let's understand the problem quickly. If the input is this array, modify it to be like this. The output should be two unique elements in this array. How about this input array? We're going to modify it in place and it will become this, and we return 5 unique elements. The key trick here, the array is already sorted, so all duplicate will always be next to each other. So you have 0 0, 1 1 1, 2 2, 3 3. Here's the idea to tackle this problem. Use pointer I to keep track of the position of the last unique element, and pointer J to scan through all the elements and compare it with the last unique element. If it's different, congratulations, we just found another unique element. Copy it to the right position of the last unique. Here comes the fun part, a visual walkthrough. watch how the arrays get modified as pointers I and j move through it step by step. First of all, set up I is position of the first unique element. So 1 is the first unique element. We will go through every other. When j at position 1, 1 is the same as 1 at position I. If the same, then advance j to the next element without doing anything. Now 2 at position j is the same as 1 at position I. No, congratulations, we just found another unique element. Advance I and copy 2 to that position. At this time, the loop ends because no more element. Position I is 1, return 2, which is I plus 1. Next example, this element 0 at position I is the first unique element. We're going to use pointer j to scan through all the elements and compare with the last unique element 0. 0 at j is the same as 0 at I. Do nothing. Advance j to the next position. 1 at j different from 0. Then we're going to advance I to the next one and copy 1 to that position. Next repetition, advance j to the next position. 1 at j is at the same as 1 at I. Do nothing. Continue, advance j to the next position. 1 at j, the same thing as 1 at I. Do nothing, advance j again. Now 2 at j is different from 1 at I. So we just found 2 is a new unique element. Then advance I to the next position and copy 2 over there. Now advance j to the next position. 2 at j, the same thing as 2 at I. Do nothing, advance j again. 3 at j is different from 2. So 3 is the new unique element. Advance I to the next position and copy 3 there. Now advance j to the next position. 3 at j is the same as 3 at I. Do nothing. Advance j to the last position. 4 at that position is different from 3. Then 4 is a new unique element. Then advance I to the next position and copy 4 there. This time the loop is end. J already go to the end of the array. I is 4, return 5. If you are with me so far, great. Let's turn the idea into actual Python code. First, set the position of the first element I equals 0. So the first unique element is at the first position. You pointer j to scan through the array from second position to the end of the array. If the elements at j is different from the elements at I, congratulations, we found the new unique element. Advance the position of the last known unique elements and copy the current element to that position. At the end, when j went through all the elements, return I plus 1. The first I plus 1 element are unique elements. Done. Let's submit to Leetcode. Oh, accepted. Perfect. Clean, fast, and no extra memory needed. If that helps you see it a little more clearly, subscribe to this channel. Welcome back. Alan here with another episode of Leetcode Simplified, where we break down problems the easy way. Today we're tackling Leetcode 27. Remove element. Modify an array and remove in place all the occurrence of val and return how many number of non-val, and we need to do it in place. Let's see, you have this array and we need to remove 3. Only keep the 2, put it in front, and another 2 non-val we're gonna put it in front, and we return how many of them? 2 element, not 3. Let's take a look at another array. So this val is 2, so non-val is 0, keep it in front. 1 is non-val, we're going to keep it in front. 2 is val, we skip that. 2, skipped it. And 3, non-val, keep it in front. 0 is non-val, we're going to keep it in front. 4 is non-val, we're going to keep it in front. And 2, don't do anything about that one. So how many non-val elements in front of the array? The answer should be 5. The approach: use J to scan through each element, and if it's non-val, copy it to the position I and advance I. At the end, I will be the number of the non-val element in the array. Alright, let's make this even clearer. Animate this step by step. Watch how our two pointer I and J slide through the array and clean things up as they go. First, initialize I at this position to keep all the non-val elements. Traverse the array with J, and whenever the element at the J position is non-val, copy it to the I position and advance I. Otherwise, the value at J position is the same as val. Move to the next iteration, advance J to the next element, and compare. 2 is different from 3 at position I. Then copy 2 at the I position and advance I. Next iteration, J go to the next element 2, which is non-val, different from 3. Then we copy 2 to the I position and advance I. Next iteration, advance J to the next and last element in the array. Its value is 3, is the same as the value we don't want. Terminate the loop because J is at the end. At this point, how many non-val elements? 2 and 2, which is 2. So we return 2. Move on to the next example. First, initialize I is where to place the non-val elements, and J the index to traverse the array. If the element at J is non-val, in this case 0 is non-val, copy 0 to the I position, advance I, repeat J go to the next element, 1 non-val, so we'll copy 1 to the I position and advance I. Next repetition, advance J, 2 value we don't want, do nothing. Next iteration, advance J 2, the value we don't want, advance again. J now E3, non-val, we copy 3 to the position I and advance I. Next repetition, advance J 0, which is a non-val, then copy it to the position I and move I to the next position. Next repetition, J go to 4 non-val, so we copy 4 to the I position and advance I. Next, move J to the last position in the array 2, the value we don't want, do nothing. This time the loop ended, no more element, so I is the number of non-val elements in the array. Return I, which is 5. Got the idea? Awesome. If everything makes sense so far, let's translate this logic into Python. First thing first, initialize I at the position where we start storing the non-val element. Then traverse the array. If the values at J position is non-val, then we copy that value to the I position and advance I. At the end, no more element, then return I, the number of non-val elements in the array that we kept in the front. Done, clean, simple and in place. Let's get ready to rumble. Submit. Boom, accepted. That's a fast, clean solution with no extra memory. Just 2 pointers and solid logic. If this walkthrough helped you out, please subscribe. We will go through each and every Leetcode problem, step by step, line by line. Hi everyone, welcome back. Alan here with another episode of Leetcode Simplified, where we break down problems the easy way. Today, we're tackling Leetcode 28, finding the first occurrence in a string, even 2 strings, needle and haystack. return the index where needle first appear inside haystack. If it's not there, return -1. Let's say you have sad but sad and the needle sad. So sad first appear at position 0, so we return 0. Whereas little appears in Leetcode, none, so we return -1. The popular technique we're using here is often called the sliding window approach, where we will slide a window the same size of the needle across the haystack, checking each substring for a match with the needle, and as soon as we find one, return its starting position. To make this clearer, let's animate step by step. Let's say the needle is TSA. Find TSA in the string sad but sad. We will build a sliding window the same size of TSA. If the size of TSA is M, then the sliding window will start at index I and end at index I plus M. Start sliding the window across the haystack. Is that fit the needle TSA? DBU, is that fit the TSA? BUT, does it fit TSA? UTS, is that the same as TSA? TSA, this substring match. We will return the index I. Awesome. Now you got the idea. If everything makes sense so far, now let's translate this logic into Python. First, define N and M is the length of the haystack and needle. Start sliding the window through the haystack for I in range 0 to N minus M. If the sliding window match the needle, return the position I. If we finish the loop without finding a match, return -1. That's it. Slick, efficient, and zero first. Time to mash the submit button. Accept it. That's a fast solution with no extra space, just a loop and string slicing. That's it for today. If this walkthrough helped you out, I'd love to hear you stick around. Please subscribe, hit the like button, and